this work is funded by the U.S. Department of Energy through the Building Technologies Office. I want to acknowledge Priya Swami. She's our program manager there at the DOE. I'm going to start off our session today just with some background and an overview of the small commercial building sector, why we are focusing our attention in that area. Then I'm going to give an introduction to how we connect to the 2030 program, as well as some of the details of the package itself. We'll then break for a short question and answer period before Robin walks us through a more technical view, looking at some guidance on how you can access building energy data, the tools that you can use to analyze that data, and we'll actually go through a live exercise using data from a real-world building. At that point, we'll bring it kind of back up out of the technical and enter into a discussion of the business model behind this service offering, the associated value proposition, and then we're going to share with you some lessons learned from pilot and larger demonstrations that we've conducted with contractors over the last couple of years, and some pointers as to how you can maximize success. So why are we interested in small commercial buildings? There's a couple of reasons. Purely speaking by number, there are a whole lot of them out there in our commercial stock nationally. Just by count, the small buildings, which we define as those under 50,000 square feet, are a full 95% of the buildings that are out there. And in those buildings, they're responsible for well over 40% of the nation's total commercial building energy consumption. If we look at how much these buildings spend on their utilities each year, it's on average about $23,000 annually. Of course, the larger, more energy-intensive facilities are spending more, and the really tiny buildings might be spending less. Now, we know from our work in the industry in energy efficiency that we can reduce energy use and utility costs by up to 30%, and we can do that cost effectively. The energy management package that we're sharing with you today targets 3 to 5% energy savings by identifying low-cost or no-cost improvement measures. So we can think of the package as perhaps the first step along a pathway or a trajectory to attaining deep savings in our buildings. It's a very low-risk way to kind of begin that journey since there's no real capital investment that's required. The idea being that as an owner gets some early successes under their belt in this low-risk context, they can then gain some confidence and an appetite for perhaps those deeper savings along the way. Within the commercial stock, there are, of course, a number of subsectors. This package and service offering is really targeted for use in 4 of them. Those are the office, retail, food service, and food sales facilities. And these pie charts on this slide show to which end uses the energy is going. And so if we look at the breakout in the office and retail sectors, those blue and red areas of the pie are showing that the majority of the energy usage is going to the HVAC systems, heating, ventilation, and air conditioning, as well as the lighting. When we start to look at the food service and food sales facilities, the mix shifts a little bit. We start to see, of course, as expected, a higher prevalence of refrigeration loads, and particularly in the food service, the cooking loads become more dominant. In both cases, however, you still see a good portion of energy going to the HVAC and the lighting systems. In terms of how these subsectors stack up against one another in their energy use, we can look at a metric that we'll return to in today's training session. I'm showing on the x-axis of this plot horizontally what we call the energy use intensity of the building. That's the combined electric and gas use in thousands of BTU per square foot on an annual basis. And you can see that the office and retail facilities are coming in at anywhere from 50 to about 60 kBTU per square foot per year. As we start looking at the food sales and service facilities, that use really skyrockets. So they're double or even triple the intensity of those office and retail sites, 200 and even 300 kBTU per square foot annually. We saw on the past slides that we can cost effectively achieve deep savings in buildings. We might even get significant savings from very low capital expenditures. And this sector is a large part of our national stock. However, in spite of the opportunities that are afforded by these small buildings, they've really historically been pretty underserved in terms of the delivery of energy efficiency services. And this is really due to two primary things. First are really tight margins. So we saw that these facilities, on an annual basis, we're talking about utility expenses on the order of tens of thousands of dollars a year, in contrast to the really big buildings that might be spending hundreds of thousands of dollars a year on their energy use. So what that means is that any services that we want to deliver have to be very streamlined with incredibly low transaction costs. If you think about the payback context, if you're saving, 10% of $10,000 a year in costs, you really get into a spot where you could conceivably, if you're not careful, blow a year of payback just from a single truck roll to the site. So tight margins are really key for this sector. And also importantly, the lack of on-site staff whose official roles and responsibilities include energy management other than writing the check to pay the bills. So those are some of the barriers behind why this sector has been so hard for us to reach in the efficiency industry. I want to now kind of with that brief context into some of the motivation behind looking at small commercial buildings. I want to talk a little bit more about the details of this package and our connection to the 2030 program. So the 2030 Districts National Initiative, led by the private sector, representing at this point well over 100 million square feet of commercial buildings, and these are in these downtown business district areas where the participants are working to reduce greenhouse gas emissions at that aggregated district scale. Now, key to reducing greenhouse gases in buildings are to reduce energy use. And in this initiative, there's kind of a ramped or phased set of targets. So by 2015, the first goal is to reach 10% savings relative to the national average, then ramping up to a full 50% reduction in building energy use by the year 2030. Lawrence Berkeley National Laboratory is funded by the Department of Energy currently in a multi-year project to develop resources and tools and a deployment infrastructure to make this initiative more accessible to the small commercial sector. So key to that is a set of tools or a toolkit of resources that are customized or tailored for the specific needs of those small commercial buildings. You can access this toolkit currently at the website 2030districts.org on this slide at the top in orange, I'm showing where you can navigate to access the toolkit for small commercial buildings. Here I'm showing us just a screen grab of some of the resources that are available. For example, a boiler calculator, an electric chiller calculator. Here's a more in-depth screenshot of something I thought would be of interest to today's audience. This is the rooftop HVAC unit calculator. These are places where you can explore the return and cost of certain improvements that you might want to make to the facility. Here's a screen grab of the lighting retrofit tool. And third, amongst many in this toolkit of resources, is the energy management package, which is, of course, the focus of our training today. So really, what is it? It's a new offering for HVAC contractors to expand their services beyond the purview of those rooftop units that may be the core focus of existing contracts, to begin to consider whole building energy efficiency improvements. Now, I covered the fact that low transaction costs are really critical in being able to effectively serve these small buildings. So delivery of this package, it's designed to take about half a day to go through each of 5 steps. This package can be, revisited about every 6 months or twice a year. One can conduct these 5 steps that can enable the identification of, again, low cost or no cost operational improvements that should garner about on the order of 5% savings. So this is in contrast to things like retrofits, which may generate more aggressive savings but require a capital investment. The 5 steps of this package are really made to leverage free, inexpensive tools that are already available on the market today. So I'm going to go through each of these elements in a little more detail and talk about the associated activities with each element, what you would actually be doing, and the contents of the package that our team have developed to support you in conducting those activities. So the first 2 elements are all about data analysis. Whether you have access to monthly utility billing data or are fortunate enough to be in a region with a smart meter rollout, the first step is to actually look at that data and see what kind of performance insights can be gained. So the package has a few things to support this effort. And first are guidelines on how to gather data from your clients in concert with your local utility, and then how to use the tools that are available today to analyze that data. And we provide for every element of the package worksheets that allow you to kind of take notes as you go and track your findings real time. The third element in the package is an on-site walkthrough. This is nothing like a full-fledged end-to-end audit, which can be very time-intensive. This is really just a 1-hour walkthrough at the site, and we provide in the package really streamlined guidance, a checklist of specific things that you can look for in these buildings. For example, familiar, I think, to this audience would be the fact that most of the time when there's a programmable thermostat, it won't actually be programmed. Similarly, we can look at occupancy sensors, whether they're installed in cases where it would be beneficial, and if they're installed properly. We also provide in the guidance materials some information on how you can fix the problems that you've identified in your walkthrough. The fourth element of the package is communicating with the owner. We can't overemphasize the importance of that step. We provide guidelines, and I will actually return to this in the latter portion of the training today, but guidelines on how you can have that conversation to sell efficiency upgrades. We also give a spreadsheet template that will allow you to transfer results from your worksheets that you've used along the way, quick transfer of that information into a few cells in a spreadsheet that will generate for you a 1 to 2 page report that can formalize and synthesize your findings and be used as the key grounding to that conversation with the owner. We also give, for this portion of the package, resources or directions on how you can work with your utility to identify incentives that could be used to offset the very modest first costs of some of the very low-cost measures you might identify. For example, if you have seen very old, inefficient linear fluorescents and would like to swap those out, there's often rebates that you can get from your utility to do that. The final element of the package is kind of a circle back, say 6 months later, where you check your results. Here we give guidelines on how to use the same tools that you used in the first steps for data analysis to validate the impact that you've had in the building. And we give tips on how to proceed. The intent behind this offering is that it's something that you go back to every 6 months or so. You can look for additional improvements. You can validate the effect that your improvements have taken and proceed down that path of ensuring persistence and identifying even further opportunities as time marches on in these sites. So I mentioned the use of, these readily available, free or very low-cost software tools to do the recommended data analysis. And in the materials that we've put together, we have a pointer to a list of relevant tools that are out there that you might choose from. And it's important to emphasize that, we give several examples that are really for informational purposes only. So they should not be, construed as any endorsement of these tools, either by Lawrence Berkeley Lab or by the Department of Energy. The other point to make here is that this is a very active part of a very active market. And so we've given a representative list of tool examples. It's certainly not comprehensive. There's kind of new ones that are being released all the time. So I'm showing here just a logo splash of some of the tools that we point to in the package. Some, like EPA's Portfolio Manager, are probably already familiar to you. So far, I've given you a pretty high-level verbal description of the contents of the package, the associated activities that will carry you to identifying and implementing improvement measures. But I want to go a little deeper now and really illustrate the use of the package from one of our pilot demonstrations. So I'll be illustrating a case from a fast food restaurant. It's pretty small, 3,000 square feet, but remember that these food service establishments are very energy intensive. So this 3,000 square foot building accounts for about $26,000 a year in energy costs. This is a site from the San Francisco Bay Area. So let's march through the 5 elements kind of one by one here. The first is monthly data analysis and benchmarking. This step requires at least a year of monthly electric and gas use. The more years you can get your hands on, the better. You've got to know the building floor area, or at least a rough estimate, some sense of how big it is, and of course the type, whether it's office, retail, food sales, etc. Once you're up to speed and trained in how to do this, it shouldn't take more than a half hour to an hour of your time. So using these available tools on the market, we plot out the monthly utility use and look for things like the seasonality of the trends. What are the seasonal patterns as we move from winter into a spring season, summer, and then fall? How does 1 year compare to the previous? Do we see a creep up in energy use, stable use, or even a shift downwards? And when we move into benchmarking, this is actually an activity that we'll do together later this morning. This is where we're comparing the building's energy use in an apples to apples kind of way with a comparable peer set. So we use that energy use intensity metric, the thousands of BTU per square foot that's used annually, and we compare to buildings of, equivalent operating hours, number of occupants, floor area, and climate, all through the use of these available tools. And we actually get a percentile score, kind of like your, standardized academic test where your building will show as in the, a certain percentile. It gives a very high-level view of the savings opportunities in the building. If you're doing really poorly relative to your peers, good indication that there are improvements to be had at the site. So in this slide, I'm showing just a screen grab of some of the contents of the package that are actually provided. So remember, for each of the 5 elements, we provide a set of guidelines to walk you through the process, which is shown on the left. And we also give a worksheet to track what you're finding along the way. So let's take a look at the monthly data for this pilot building. On the upper left-hand plot, I'm showing electricity use. On the bottom right-hand plot, we're showing natural gas. And we've got 3 years of data plotted, 2011 in blue, 2012 in red, and 2013 in green. If we take a look at the electricity use trends, we see that the lines are kind of all on top of each other, showing that the usage is pretty constant from year to year. That's in contrast to the natural gas plot, where you actually see a separation between the lines, no real overlap. As we move from the blue in 2011, usage creeps up a bit more for the red line in 2012 and even higher in 2013. So we get an immediate clue that in this facility, there might be something happening with the gas usage, and that's for further investigation in continuing to look at the data, benchmarking, and walkthrough. So we keep that in mind, that perhaps something is happening with gas in this facility. Next thing we can do with this monthly data is benchmark the building. This benchmarking does not require smart meter data. You can do it just with the utility bills. In this case, we actually used a tool developed by Lawrence Berkeley Laboratory instead of the EPA Portfolio Manager tool. This is only because Portfolio Manager didn't have coverage of those fast food restaurants. So we used this other tool to benchmark the site against all the fast food restaurants in California. And we were actually surprised. We found that a full-on 85% of the comparable restaurants out there were using less energy per square foot. So this was like in the 15% of the most energy-consuming buildings in the state when we normalize for the appropriate factors like hours of operation and so on. So this lets us know, hey, relative to peers, this building's not doing so well. There probably is opportunity for improvement that we can further investigate. So the second element is to get our hands on smart meter data where it's available. We also call this interval data, and see what we can find from those trends. So this is going to require 3 to 12 months of data. The more, the better. similar to benchmarking and monthly analysis. This is about a half hour to an hour of your time. Here we get a more granular look at the energy usage profiles. We can start to understand how much energy is being used at specific times a day. And so we can ask ourselves, are the daily and weekly load profiles as we might expect? In this example on the slide, you can see very clearly a kind of Monday through Friday business operation with less usage on the weekends. You can also incidentally see the Martin Luther King holiday on this first Monday shown. We can look at how much energy is used at night, on the weekends, relative to those midday periods. In looking at this type of data, we always want to try and identify strange spikes or things that jump out as unusual. We can also, of course, look for changes over time if there's a real stable behavior or if we see trends upward or downward. Here's a couple screenshots again of on the left, the streamlined step-by-step guidance on what to look for in the data, and on the right-hand side, the worksheet to track what you have found in the data. There's really two options that you have to look at interval data. You can do it yourself, or you can order automated analyses. This is a sample report page from a company called Energy AI. If you send them a year's worth of data and $50, they'll generate a report that summarizes all of those aspects of the load profiles, the holiday shutdowns, the overnight and weekend loads, the anomalous behaviors, and give suggestions as to ways to improve energy usage in the building. So I want to take a look at the interval data kind of in the do-it-yourself vein from this pilot building. And this is two plots here. On the upper left is a week in winter in January. On the bottom right is a week in summer from June. On the y-axis, we're showing the electric load in kilowatts for this restaurant. On the x-axis, we're showing time of day from early morning into the night period. Every line that you see on a plot is one day out of the week, from Sunday through Saturday. So as we look at these plots, I'll actually ask Sam to help me in working some with the in-class audience there. And I just want to give a call out and see if anything strikes you as you observe these plots as interesting, unexpected for these load profiles for this building.
Yeah, I think it's interesting that they have so much electricity this before and sleep ban. I'm wondering if they are making them at that time, or preparing rice or something like that.
Jessica, can you hear that?
Sam, could you repeat, please?
Yeah, so the early morning electricity use is pretty high.
Exactly. So there's this, whether you look at the January or the June plot, there's this interesting peak that we see between those hours of 4 to 6 in the morning. Anything else jumping out at folks about these profiles that we see? Okay, well, the other kind of interesting or not so usual aspects of this profile is actually, you know, it relates to the first comment that was made, but the usage in this site is lowest during what we typically think of as those core business hours. So, you know, at 8 in the morning, at noon, at 4, this is 4 in the evening. This is where we actually see the lowest loads at this site, and that's a little bit different. So we'll actually.
Just give me a moment. Yeah, never mind.
Okay. So we'll come back to what was the cause of some of this and what was the remedy when we get into what this site actually found in the walkthrough. So after you get your hands on data and analyze it, the next step is to conduct a walkthrough. And this is a 1-hour cruise through the building to check things like lighting and thermostat settings, to talk to that on-site point of contact who's probably some kind of business manager, but can still tell you something about the energy management practices, habits, and behaviors of maybe the customers as well as the employees at the site. Here's a list of some of the guidance that we give, and I've bolded just a few examples. This is things you might look for in your walkthrough. Are the doors or windows kept closed during those intensive heating and cooling periods? Are thermostats programmed? Are they programmed to set back during unoccupied hours? For offices, are those copy machines, computers, printers, and fax machines put to sleep or shut down at the end of the day? And so on. So here's a quick list of things that you can check for in a 1-hour walkthrough at the site. So when we conducted or delivered the package to this pilot site, we were able to take the data and have a discussion with that point of contact business manager about these kind of strange load profiles that the contractor saw in the data. And there was an interesting explanation for what's going on. So one of our attendees today pulled out immediately that strange hump around 4 to 6 a.m. This is actually all of the external parking lighting blasting on at the same time early in the morning. As for those high peaks that happen, after 4 p.m., we found that this is a 24-hour facility. And so the drive-through is running all night with a good amount of business. And so that's why we're not really seeing any reduction of load through that overnight period. So in consult with that on-site business manager, a few opportunities were identified. First, there was no reason to fully light the parking lot at those levels so aggressively early in the morning. There was also opportunity to look at the dining room area and reducing the levels and hours of lighting there. And of course, in almost every building we go to, there are opportunities with the scheduling and the setback levels on those thermostats in the staff and dining room areas. Our contractor in this case also noted a few add-ons. He was going to check the gaskets on the refrigeration units and take a look at the kitchen equipment and all of the cooking loads to see if there were opportunities for higher efficiency units. The fourth element was that owner or point of contact communication. Here's where we provide in the package that summary generator based on your worksheet answers, and I've got a screenshot of that on the right of this slide. Pointers to how you can work with your local utility to look for incentives, even for the very low-cost improvements that you might be coming up with, and guidelines and tips on how to work with your point of contact to set goals and actually implement the measures that you identify. So you might be able to use your benchmark score as a conversation point to say, if we do these 3 things in your building, I think we can improve your score by 5 or 10 points this year. Fifth and final element is to check results. This is where you return to the data from the site about 6 months later. This is another half hour to an hour kind of investigation where you're using the same tools that you used initially and looking to answer questions like how much energy has been saved over time. Can you verify changes to scheduling? Do you see changes in the load profile, et cetera? Now, you can use this look back on results to identify even more improvements that can be made. but perhaps more importantly, to have a documentation and record of your impact and success in actually affecting reductions in these facilities. And that can be used, I'll return to this point later in the session, but that can be used as good documentation for future sales opportunities. So I want to take a break here, and again, I'll ask for Sam's help to kind of make sure that I'm hearing the questions okay, but I want to open it up for a little bit of dialogue on any of the material that's been presented so far. We had the overview of the small commercial sector, why we care about small buildings, some walkthrough of the contents of the energy management package, and an example from one of our real-world pilot buildings. So let's open it up. Our team can take questions, or if you just want to make some observations and comments, that's great too.
Jessica, can you hear me through this mic?
You sound a little underwater.
Okay. Probably
oh, that's much better.
Oh, it is? Okay.
Hey, Jessica, it's Andrea.
Hi, Andrea.
So given that we're working in an area that currently doesn't have widespread smart meter rollout, can you make some suggestions about how we could look at monthly bills and get down to, I mean, we don't have quite the granularity, but the observations that the contractor got in terms of, oh, the parking, here's when the parking lights are firing up, and here's certain hours of the day when we could change how our building is operating. Can you recommend how we might be able to get down to solutions of that level utilizing monthly data as opposed to hourly?
Sure. So there are, I'm going to answer in two ways. Depending on what data analysis tool you choose to look at, you'll get more or less sophisticated analyses. So there is a tool out there that's free, that's offered by New Building Institute, that's called First View, and that actually has some intelligence behind it. It will take monthly utility data, and using some building science intelligence will take that information and kind of break it out into what component of the whole building energy use is going to heating, what's going to cooling, how much is that overnight kind of electrical base load, which is, you could think of your sleep mode usage for the building. And it'll generate for you some recommendations based on that algorithmic disaggregation just based on the utility billing data. The analysis exercise that we're going to go through this morning with you all, doesn't actually use the First View tool. It uses one that's a little less sophisticated in the information that it will provide. So there's one option, is that you can look for those monthly analysis tools that are still free or low cost, but have a little more technical meat behind them. Secondly, there's a lot to be gained from benchmarking the building just in terms of some of the insights that can be gained there. And third is the importance of the on-site walkthrough and the conversation with that point of contact. So even in the example that I gave, we could see with using the interval data, we could see strange or interesting things happening in the load profile. But it wasn't until we actually went to the site to have the discussion that we could actually figure out what was going on. So I think that for the regions that don't have the smart meter data yet, like the Pittsburgh area, there's still a lot that can be gleaned from the monthly data, and it goes hand in hand with that on-site walkthrough. I guess I can make one more comment. a little add-on there, which is that the Berkeley Lab developed benchmarking tool that I mentioned, Energy IQ, it's actually called an action-oriented benchmarking tool. So it goes one step further than some other benchmarking programs in that it asks you for a little information about the site. For example, what do you know about the lighting equipment or the HVAC equipment? And it takes that user-provided information and combines it with the benchmarking database to actually generate improvement recommendations. So that hence the action-oriented nature of the benchmarking.
I just wanted to also add to Andrew's question that you could put in some data markers if you wanted to for temperatures in the space to see if the temperatures are going down or running, or lighting waters to see what's happening. I had a question about your EUIs. Do you use the site where you just take the energy use over the square foot, or do you use the source numbers for that?
Can someone closer to the microphone please repeat the question or the comment?
Can you hear me?
Yes, I can.
Just the question was about the EUI calculation and what figures are used for that. Is it square meter or energy used from the site versus?
There's two different numbers for the EUIs. There's either the site data, which is the kBTU over the square foot, or to use the source where you factor in where the electricity comes from. You know, if it's a coal-fired plant or a hydroelectric. Because I've noticed both numbers in different reports, and I just wondered if there's a standard for that.
Great question. So this is getting at source versus site energy and which is used in the benchmarking. So site energy is actually the standard convention for what's used. Site energy is just a measure of what's being consumed at the facility. Source energy, on the other hand, takes into account all of the energy that it took to actually produce and deliver, for example, the electricity that's being used on site. So it kind of traces things back to the generation side. But to answer the question very specifically, the EUI that's used for benchmarking is site energy consumption only. We don't take into account, you know, the coal that was burned to create the electricity to begin with, or the hydro, as the case may be.
Hi, Jessica, can you hear me?
Yes, I can.
Oh, it works. Great. This is Kevin Ketchman. I'm with the University of Pittsburgh. I'm just curious about the calculators that you have working with this tool. You showed us, I think early on, it was a rooftop unit. Some of the other calculators, I know they're through like the DOE and Energy Star. But my question is, are those tools, are those calculators actually talking with each other? So if I'm a building owner and I make an adjustment, say, to my insulation level per a calculator, does that then relate or go back into the rooftop unit calculations and adjust what my savings would be?
Oh, that's a really great question. I think, Kevin, that the answer is, unfortunately, this is a collection of standalone tools. So I do not believe that there's any connection on the back end that will repopulate or update things across the individual tools.
Actually, they're working currently on a whole building retrofit calculator. meter, and that's going to have those capabilities, but it's not quite ready to be deployed yet.
Oh, good information. So a couple of them, it sounds like they're working to integrate them from the whole building perspective to perhaps include some of the others. Great.
I think that's all the question and answer right now. So.
Okay.
Oh, sorry. There's one more over here.
Good morning, Jessica. This is
Good morning.
from Scala Solar. I do have a question about when do you ever recommend that building owners put in their own auditing systems, like say flow meters or BTU meters, if they're heavily using hot water or like a TED for their energy analysis, and to see what their spikes are for their electric usage during the day?
Oh, good question. So I think that's getting at the value or benefit of more and more granular metering. So at the first pass level, every building out there has monthly utility billing data. In some regions of the country, we can get more granular and look at smart meter data, which will break things out hourly on a time of day basis. And then that's still all at the whole building level usually. There's also, of course, the option to meter even more deeply in the building. This is referred to as sub-metering. And the question was specifically about, things like, do we recommend that owners make use of things like BTU meters for their heating or cooling systems on the hot or cold side, as an example. So there's absolutely value to that information, where we can get it, and where it's cost effective. So if we're talking about really small commercial buildings, those under 50,000 square feet, they probably don't already have that information. They may not even have those kinds of systems installed. And there, we recommend that you gain everything you can from the existing available data for the facility. If we think about larger buildings, there's often a building automation system or control system, and some of these points may be trended and available for analysis. And they are absolutely provide value and the ability to kind of drill down and gain deeper and deeper understanding of where the energy is actually going. So did I answer your question well?
Yes, I was just wondering if there was a certain point, square footage-wise. I was just wondering if it was a certain point at square footage-wise or usage-wise where you recommended that. I mean, being that, a BTU meter installs, a couple $100, and you can get a TED with 5 CTs for, probably 300. It's not that big of an investment for even a small building like the one we looked at, the restaurant.
Yeah, there are a couple of factors that are at play. There's the cost of installation and implementation. Even there's hardware costs and there's also labor costs. And usually the labor and install costs will often surpass that of the actual hardware that you're trying to install. Another consideration is who's going to be making use of the data and actually looking at it. So that always has to be somewhere in the mix, is how does the information play into the services that are being procured for that building. So I wouldn't say that there's a hard, fast cutoff in terms of square feet. It's kind of the interplay between how much is being spent annually on utility costs, and how does that impact the payback or return on that more granular information that you can obtain. Okay, so we're going to do a quick handoff here in terms of presentation mode. Robin's going to take us through an overview of how to access tools and data, and then we're going to probably stop for a short break for you all before diving into our actual data analysis exercises. Robin will also be leading there. So let me transfer control back to GBA, who can hand over to Robin.
Okay, so I'm Robin Mitchell from Lawrence Berkeley National Laboratory. I work with Jessica and Sam on this project. And so I'm just going to go through a little bit about getting data. So if you can get, so it seems like everyone should be able to get monthly data, and in order to do the monthly data analysis, it'd be good to get at least 1 year of monthly electric and fuel use information. And you also need, and more is better, is always better. If you can get a couple years, that's always more interesting. And you need the building floor area and the building type in order to benchmark the building. And so entering that data and doing the benchmarking should take between 30 and 60 minutes. And the benchmarking tools don't necessarily require monthly data. In a lot of cases, like the one we're going to look at today, Target Finder only needs total annual consumption. But it's good to be able to look at the monthly data in order to get more information about how the energy is being used in the building. And then ideally, what Jessica's been talking about is that you could get interval data, so hourly or sub-hourly data, but it does require some sort of smart meter, or as somebody was, or a couple people have suggested, you could put in some data logging, but again, that costs money and it may not be cost effective. But if you can get interval data, it's good to get 3 to 12 months of that data, and again, and usually that's downloadable. The monthly data you might have to input by hand, which we'll do later. The interval data is usually downloadable, and then you can just import it into the software tool. And I just briefly looked at the Duquesne Light website, and it does, and you guys probably know more about this than I do, but I thought I would just put this slide up, that it does seem like there's a smart meter installation plan ongoing in your area starting in 2014, going for the next 5 years. And it did seem like you could request a smart meter to be installed, but again, you know, the cost of it was pretty significant. So for a small commercial building, it might not make that much sense. But it does seem like that, you know, things are moving in the right direction in your area for getting the interval data, which is actually the most interesting of all the data. And I did find this little commercial energy calculator on the Duquesne Light website. And again, it's what Jessica was talking about, that you know, it's a little bit more information about a building. It has some smarts behind it that where it tries to break out where the energy, by end use, where the energy consumption is. So again, you know, it's always interesting to first investigate all the tools that you can use or the data that you can get from the utility. And then the only issue is access to someone else's data, because basically you're trying to look at data that isn't yours, it's the building owner's, and so it may be tricky to get that set up. But if you can, it's always interesting to investigate what tools the utilities have themselves. And then in terms of the interval data types, which again may be a little bit, you may not be able to get your hands on this data, but the smart meter data in general uses what's an XML file. So it's a text file, and it has these tags that say what kind of information it is. And so it's not really very human readable. I mean, you can figure it out by staring at it, but it's just not very convenient to do, and it's really required, I mean, it's really designed for software tools to read it. But then sometimes you can get that same interval data as a CSV file. So again, a text file, but in a format that a person can actually understand and that you could import into a spreadsheet, and maybe you could do some analysis yourself just with a spreadsheet. And then accessing the data if you want to get monthly or interval data, you know, can you get it directly from the owner? And sometimes it might be that they've gotten some sort of electronic copy, but I suspect in a lot of cases it's going to be just hard copy of the bills that you would enter by hand. And then sometimes utilities have third-party authorization forms where the owner can, or you can request authorization and the owner can give it to you, and then you can directly access their utility data, or from the utility, and then the other possibilities that the owner would actually set up an account for you, or let you access their account with a password or something like that. And so in the end, you get either monthly or interval data, and the annual or monthly data allows you to benchmark the building, so that's where you're comparing your building to your peers. And then if interval data is available, you can do these more detailed analysis, but if it isn't available and you only have monthly data, then you can use GreenQuest, which is the free tool that we're going to use today, or some of these other tools that cost a little bit, but not very much. And I did want to just show, we'll have the URL at the very end, but I did want to show that we have a website that has all this information on it. And one of the links on that website is software tools. And so here is information about tools to do monthly analysis, benchmarking, and interval data, and with links to all of the different ones. So here's First View that Jessica was talking about. Here's GreenQuest that we're going to use today. So anyway, and the URL is in the
Hey, Robin.
Yeah.
Can you load the presentation? I think the presentation's not good.
Say again?
Is the presentation open on your computer?
Yeah, I switched to another application,
Oh, okay.
and maybe that caused it to not show up.
Yeah, quickly, if you open the sidebar where you have the controls on the right-hand side, there should be a little button there that says select what to share.
I see.
When you click that, you'll have to check on the PowerPoint or whatever PDF or whatever.
Yeah, they're all on.
Okay. Yeah, right now we're just seeing your browser.
Interesting. This
Could you turn off the browser and just recheck on your presentation just to see if we can get something to change?
Yeah, Robin, maybe if you go into full-on presentation mode in your PowerPoint.
I am.
Oh.
No, here we go. Something's happening.
We got it, Robin.
Okay, now we can. We're
okay, I want to just try if I well, I guess I closed it. Okay, well, I'm hoping that I can switch between different.
Yes, you would
things.
be able to. Yeah, you should be able to. No problem. Go ahead and try just to make sure.
Yeah. So so can you see the GreenQuest screen now?
Yep.
Yes.
Okay. All right. I guess it's because I pulled something from my other monitor and it switched the monitors is what happened.
Oh, yeah, that will. But you're good now. So.
Okay. All right. So okay, and then here's the URL where you can look at the different software tools, and there's links to all of them. And so today for monthly data, we're going to look at GreenQuest, and for benchmarking, we're going to use Target Finder, which is a slightly simpler tool than Portfolio Manager that's also developed by EPA. So did you want to take a break before we start the data analysis exercise?
Yeah, I think we can take a quick 5-minute break before we get into the meat of actually walking through this exercise, so folks in the room can stretch, do what you do. We'll come back in 5 minutes.
Okay, we'll just keep this going, and we'll just hear you, and we'll get in touch whenever we're all back. Okay.
Great.
Okay. Thanks, Robin. Or that was Jessica. Yeah. So I do all the media, the applications, and all the websites. So basically, everything behind the boring stuff. Yeah. We try. I don't know if it's actually designated, but it is despite it was obviously one of the largest buildings in the area. So 3 brickyards, 5 years. This is before steel. Everything vaulted and stuff. It's a hippie building. And it was a full storage. There's actually 3. We're actually on the 3rd floor. We're actually the 2nd floor of the building. There's 3 sub-3 full storage. So that's kind of the history of it. It was a terminal building. Food would come in and stored, first refrigerated. So that's the history of it. But as far as actually being designated, that's a good question. I don't think it actually is. You came in from Texas? Oh, you came in from California. Okay. Oh, you went through Texas. Right, got you. Okay. So you live up in Berkeley? Yeah, okay, that's right. That works out. With a bunch of friends from high school. They don't they stay down there. They can't afford it. Very expensive, but seems like that's not where you're from? No. Yeah. Oh, really? Yeah. Oh, really? Nice. Okay. What part? Oh, okay. Nice. So you adjusted well? Oh, yeah. I never, honestly, have been just... Yeah. I've never been in the area before. I'm never there. No, so you're that helps too. Okay. You know what? But no, connection. Sure. Yeah, but it'll be good to get training everyone. You're right about that. Yeah. Yeah. So you're still yeah. Geez. Yeah. It's not a hug or anything. Yeah. Okay, I think we're going to get started back up since everyone's back in the room.
Robin, are you able to hear us?
Yes. Okay. We can go ahead and get started.
Yep.
So the next thing we're going to do is to actually interactively run a couple of software tools with a example building, data from example building. So I think Sam may have handed out some hard copies that you can use to work off of to enter data. So the building we're going to look at, or that we're going to analyze, is an office building in Pittsburgh, built in 1960, 10,000 square feet, and occupied 50 hours a week. So basically just 5 days a week, 10 hours a day. And then there's electricity and gas consumption down below here. So the first program we're going to use, the first thing we're going to do is to do some benchmarking. So basically, we're going to compare this building to similar buildings, what are called a peer group, and the program will calculate the energy use intensity, which is the energy use per square foot site energy, and then it will also give us an Energy Star score. So the tool we're going to use is the Portfolio Manager Target Finder, and maybe you have already used Portfolio Manager itself to analyze buildings, but we're going to use Target Finder just because it's a little bit simpler input, it's a little bit quicker to use, and it is really set up for buildings that haven't been built yet, for design, analyzing a building design, sort of a quick analysis of a design, but there's no reason why it can't be used to evaluate existing construction. You just have to kind of ignore, where it says design and just think, well, this is my built building. It's not the design. And one of the things that's nice about this is that you don't have to actually create a user account in order to use it. So the first thing we should do is you should just, I assume everybody has a laptop or some sort of a computer, so you should enter in this URL, which is on the sheet that you've been given. And it's basically portfoliomanager.energystar.gov/pm/targetfinder. So if you can just enter that into your browser, you should see this screen then, where it says Portfolio Manager Target Finder.
Robin, do we have a minute, please?
Say again? I can't hear you.
Just a minute, because not everyone has a laptop.
Okay.
For those of you who have a laptop, boot it up.
Sorry, I'm going to give everyone the password as well, so just bear with us 1 minute. So those of you who need to get online, there's another GBA guest login or signal you can use, and then the password is capital G go, capital G green, 1, 2, 3. Just give everyone just 2 or 3 minutes to get logged in.
So about how many people are there, and how many people have laptops? Do at least half the people have access so people can share?
Yeah, it looks like yeah, it was about half. So
okay, that's good.
Then we need another computer. We get on the screen. Okay. Let's get sharing.
Okay, so everybody's set up, so they are on this page, I guess. So you can give your building a name. I'm just going to call it office, but you could do whatever name you want. And then you can select the country, which is the United States. And none of the address information is required. You could type in the city if you want to. And then you select the state, which is Pennsylvania. And then the postal code off of the sheet is 15206. And the year built is 1960. And then you need to select the primary function. And in this case, we'll just select under the office category, just the standard office. And one thing I noticed about this software is that if you mess around too much with this function, like you add a hospital and then you change it back to office, and the program can get confused. So it's good to try to just get that function set the first time correctly. And if you end up having to mess around with the data, it might be better to just close the browser and start over again. But hopefully nobody will have that problem. And then it's 10,000 square feet. And we'll just say that it's a single building. Under this, how many physical buildings will be part of your property. Then under property use details, you can see that it figured out that it was an office building under building use. And it filled in the floor area for you. And I would say let's just use the defaults. Just check all these use a default buttons. I'm going to mute myself in just a second and cough. I have a cold. So just check all the use default values. And if you did, take the time to figure out what the operating hours were and such in a real building, you could use, you could put in the real values if you want. But for this exercise, we'll just use the defaults. And then under the estimated energy section, it defaults to doing electricity. So is everybody to this point?
Robin,
I could
you hold
pause.
on a minute,
Yeah.
please?
Yeah. Let me know when people are caught up.
Okay, yep, Robin, go ahead. Robin, if you go ahead.
Okay, so the next thing we want to do is enter the annual energy consumption for electricity and natural gas. And the program gives you, for starters, a row for electricity, but you'll notice that the default value is kBTUs and most bills are in kilowatt hours. So we'll make sure to get the units right and change it to kilowatt hours. And if you look at your sheet, it's 107,620 kilowatt hours. And then the rate is, and this is, just sort of an average electric rate, not very detailed, 8 cents a kilowatt hour. And it defaults the units for the rate based on what you set the units to be for the actual bill. So now we have our electricity in there, and then this little link down here, add another entry. If you click that, then you can put the natural gas consumption in, and you can enter fuel oil and all that kind of stuff depending on what kind of building you have. So for this case, we're doing natural gas, and in this case, the units are therms. They could be in, 1,000 cubic feet or whatever. So we have off our sheet 4490 therms at a cost of 37 cents per therm. So let me know when everybody's got that entered. So has everybody got the utility data entered?
One more minute. Sorry.
Okay.
Yep, Robin, we're ready.
Okay, so now you've got your, so again, it says estimated design all through everywhere, but it's really just your building, and it's not a design building. And then this target, I would just leave it to default to 75. So it's this is optional, and you can use it to see how you rate with other buildings. The 75 Energy Star score is when you can actually say that your building is Energy Star certified. And maybe in the beginning yours won't meet that target, but so you can just let that default and see how you compare. So then you click the View Results button, and the program will calculate your Energy Star score. So you should get 52, and because it's less than 75, you can't, get the Energy Star label or whatever. But it means that, there's room for improvement, and you can work with the building owner to try to figure out how to get a better score. And so it says here the estimated energy is 31% less than the design target of 75. But actually, the design uses 3%, uses 3% less, or is 3% better than the median property. So you're doing a little bit better than the median office building, and you can see that in the graph here. So here's this building. So, and here's the target. So the target's considerably lower than this building, but on the other hand, the median property, so an Energy Star score of 50, uses actually slightly more energy. And you can see the numbers down here in this little table. So what we were talking about before, site energy use, here it is for your building, what's called design in this case, so 81.6. And then that target, so a building that got an office building with an energy score of 75 would be using 62 kBTUs per square foot. And then the median property, so a building getting an Energy Star score of 50 gets a score of 83.8. So your building is doing slightly better than the median, but not as good as the target of an energy score of 75. And then,
Robin, if I could jump in just with
sure, yeah, definitely.
Here. So for the audience and participants today, this is all basically percentiles. So the median is that 50th percentile, complete middle of the pack. When we have that target of 75, that's really saying that you want to set your goal probably to be in the top 25% of users. We know that there's a lot of energy wasted in buildings, so you probably would not want to be comfortable with being average. You can think of that 50 to 75 range as presenting a lot of opportunity for improved energy performance in the building. If you're up there in the 75, 80, 90th percentile, then you're doing very well relative to your peers. That, however, doesn't preclude the opportunity for further savings. So just a note there, I would not recommend to feel comfortable by being average. You really want to try and get up to the higher end of that range.
Okay, and so, and you can always go back and edit your information if you needed to change something. It takes you back to that previous screen. And then this at the bottom, if you want to save your design, you can't really save it in this Target Finder world. Saving it means that you're actually going to make an account in Portfolio Manager and put it there. But the inputs are easy enough that you can just, it takes 5 minutes or something once you get the data to input it into the program. So it's easy enough to just start over again. And if we look at going back here, if you go to the package where all those worksheets were that Jessica was showing you earlier, there is on element 1, which is on page 11, step number 4, there is a section to enter in the benchmarking information. So you can enter in the energy use intensity, and that was from this, so that was the 81.6. Oops, I didn't get it right, 81.6. And then the comparison ranking is the Energy Star score, and so that was the 52. So you can enter those two things into that worksheet if you want to. And then I just put little, you could add little notes to yourself. I just kind of typed in how it related to the median, and then how it related to the target, that kind of thing. And then it was an Energy Star rating. So are there any, so we've now benchmarked our building. So are there any questions about this step? Okay, so the next piece of it is going to be a little bit trickier because we actually have to make an account for this one. So we're going to look at monthly data, and we're going to use this software called GreenQuest. And so again, if you type in this URL, which should be on one of your handouts, www.mygreenquest.com/app.php, you should get to this screen here. The GreenQuest screen. And so what we have to do is we have to make an account, and then you have to check your email and click on a link to activate the account, and then come back to GreenQuest. So hopefully that's going to be possible for at least a few people to do, and if not, I can just kind of walk through the software, but hopefully you guys can check your email, at least some of you can check your email. So, and what I would recommend is to write down your username and your password before you even enter the information in here. So I'm just going to go ahead and fill mine out, and then I'm going to wait. Oops, my username. Yeah, so you get your username figured out, and then enter in the first name and the last name and the password and all that kind of thing. And then the thing to remember here is the zip code and the building type. We're using the free component of this GreenQuest software, and so it's a little bit more limited than if you were using the version that you pay for. And in the end, if you do a lot of these and you like the software, you might go ahead and just set up an account and pay for it. But the zip code is going to determine your location, and the building type that you select here. Those two things won't be, you won't be able to change them once you set them up here. So just so you know. And we'll pick general office. And then you have to check the I agree to the terms and conditions or whatever. And then click submit. And right, a login link has been emailed to you. And so you do actually have to go back out to your email. It hasn't gotten there yet, looks like. There it is. So you'll get an email called GreenQuest Accounts. And you click on that, and there's a link, please activate your account by clicking here. And then you can click on this green link and then start using GreenQuest, and it'll take you to that same screen that we were on before. And then you can log in. So I'm going to wait until everybody gets to this point where they actually could log in.
Do you have to set up one of these for each building that you do?
Well, you can delete data and then re-enter it. But what I have been doing is setting up different accounts. They allow you to have multiple accounts per email. But, really, if you're going to do a whole bunch of buildings, you should just probably sign up for the, and pay for the software. It doesn't cost very much. It would just become very tedious if you were making a separate account for every single building that you were doing if you're doing lots of buildings. So I would recommend, using the tool to see if you like it. It's only one of many. And then, you can pick from the tool that you like the best for your final tool that you might use over and over again. So when everybody gets to the point where they've been able to log in and they see this Welcome to GreenQuest first screen, let me know.
You can proceed if you want. We're all here.
Okay. Okay, so the first thing to do, you can click on either the step 1 or you can just click on My Building. And so here's where I was talking about that it sets the location and the building type, and you can't really change that. So for your particular account, again, it's because it's the limitation of the free tool. So the year built 1960 and the floor area 10,000 square feet. And I don't have demand information about this building, so I'm going to leave the track electric demand unchecked in this case. And then you can click the Save Attributes button. And then go to the My Meters section. And by default, it sets up, it says that you can enter electric information, but I also want to have a fuel meter, so I'm going to click this Turn On button for the fuel meter, and then it defaults to the units of cubic feet, so I'm going to edit that and change it to therms and save the settings. So when everybody's at this point that they've got their electric meter on and the fuel meter turned on with the unit set to therm, let me know.
Yep. Yeah, Robin.
Yep. Okay, so everybody's ready? Okay. So let's enter the electricity information first. So just for the electric meter, and again, there's a couple ways in. You can go to My Bills, but we can just do it from here. So click on the Enter Bills button, and you'll get into this screen. And we're going to enter the information 1 month at a time. So this will be a little bit tedious, but it doesn't actually take that long. And the program gets the date. Once you get the starting date, it will set the dates for you automatically. So click the plus add button. And if you look at the handout that Sam gave you for electricity, the first month is 12/2/2012. So I'm just going to type it in, 12/2/2012. And then it defaults, if you tab, hit the tab button to get to the end reading date, it tabs 1 month ahead, which is right. And then you can just enter the electricity consumption, which is 6430 kilowatt hours. And the cost is $514. And then you can click the Save Bill button. And then it saved that first month of data for you. And then you can click Add Again. So you'll just do this for the 12 months of data that we have. Click Add Again, and you'll see that it increments the dates for you, so you don't have to worry about the dates. So now it's saying this is from January to February of 2013, so you can just let the dates default and don't worry about that, and just type in the actual kilowatt hours and the money, the cost. So I'm just going to work away doing it on my side, and then you can do it also, and then just let me know when people have gotten all their data in. So Sam, just let me know, or someone just let me know when people have gotten their data in for the electricity bills.
Just a minute more of Okay, Robin, I think we're
Okay, good. And we're just doing 1 year's worth of data, but if you have multiple years, you can enter it in, and then the graphs will plot all the different years, as Jessica was showing you in one of the slides before. So as usual, the more data that you can get, the better off you'll be. But we're just doing a year, but just to make it simple. So the next thing let's do is to enter the natural gas bills. So click on the right-hand side where it says natural gas bills, and basically we're just doing the same thing. So just click the add button, and then make sure you start on the right date, so 12/2/2012, and then it'll default the dates 1 month ahead for every month that you enter the data. So then just go ahead and, again, just making sure that the units are right, so it's in therms, and then enter the cost. And so you can just work through the 12 months of data again on the natural gas side. So Sam, just let me know when everybody's got their natural gas bill data in.
Yep, just a minute.
Yep.
Yep, Robin, I think we're right.
Okay, so now that we've got our electric bills and our gas bill data entered in here, I'm going to skip some of these other options and just go straight to advanced. And so here is where, the first thing it shows is this energy recap, and the first tab is usage for your electric bills. And so it plots this nice graph of what the energy consumption is. And so we can see, so this is electricity, and so we can see in the winter, this is probably sort of the baseline electric load. And then in the spring and summer months, it peaks, and it peaks in August. You can hover over the points, and it shows you the actual month and the data. So this would indicate, right, that there's electric air conditioning in Pittsburgh. So the electricity bill goes up when it gets hot outside. And Jessica, feel free to jump in anytime if you want to give more information about sort of, how to read these graphs.
Sure. I'll just point out that, we won't go through every word of it, but the tool offers these kinds of tips to you in the text boxes on the right and suggests how you can kind of toggle between looking at your kilowatt hour consumption in this case and your cost spend in terms of dollars. So there are these little tips in the margin there that you can follow.
So it seems, that seems pretty straightforward. The electricity makes sense. And then if you go to the natural gas link, again, same, sort of looking, so the gas consumption is high in the winter, so presumably there's gas heating, and then it goes down to some baseline in the summer, and then it goes back up in the winter, so that, seems fairly normal. There are these little blips here, so it might be worth investigating, why, is there some reason that there's a little bit more natural gas being used in July and September than in August and June. So Jessica, do you want to say anything about this graph?
I think the other thing to key into is that you may want to also kind of look at the ratio between how much gas is being used in those real peak winter months, around 600 therms or so, versus how much is being used in the dead of summer. And that's around 200. So you could ask yourself, based on what you know about the building, does it make sense that summer usage would be about a third of what you see in the winter? Or is something going on, is there opportunity to crank down even further in those midsummer months?
Okay, so now we have, these two graphs show us the basic consumption information. Now, another interesting thing that you could do with this particular piece of software is look at usage versus weather. And so you click on this usage versus weather link, and it will show you, so the black line is your energy consumption, and then the blue line in this, so the particular case we're looking at now is electricity consumption in the summer. So we're looking at cooling degree days. So the blue line is cooling degree days. So as it gets, as the cooling degree days get higher, as they increase, then the electricity consumption increases.
So one comment on degree days for people who may not be familiar with that measure. It's effectively a number that takes a look at how hot it is on any given day and how that relates to kind of the average temperature and factors in what's referred to as the building balance point. The balance point is, for a lot of commercial buildings, somewhere around 65 degrees Fahrenheit, and that kind of marks the swing point between which, you know, anything higher than 65, you're probably in cooling mode. Below 65, after some point, you're probably going into heating mode. And sometimes there's a little flat region, maybe between 60 and 65. Your building's not consuming anything more for heating. So generally, you can think of degree days as a measure of how much heating or cooling is being required due to the outside air temperature and the dynamics of the building itself. So we talk about cooling degree days usually in summer and heating degree days in winter.
And so speaking of winter, so now we're still in electricity consumption, but let's look at the winter tab. And so it's always, even though, you know, we're surmising that this building is heated with natural gas, it's always interesting to look at the electricity consumption even for winter to just see if the data makes sense. So again, here are the heating degree days. So they're low in the summer and they're high in the winter. And then you can see that the electricity consumption is low during the high heating degree days and is high when it's no heating degree days. So, you know, the building is not really keyed, you know, it's not really acting on when there's heating degree days on the electricity side. Do you want to say anything more?
The scatter plot that, so there's kind of two views into the same data that's being showed here. The scatter plot on the left with the dots and the line are showing you how much energy is used versus the number of degree days. And the line is basically just showing you a trend. So this is as we would expect that as the heating degree days are decreasing, then we see the appropriate trend on the electric usage in this building because the gas is what's being used to heat. If you were to see a lot of scatter and no clear trend downward or upward to these plots, then that might indicate to you problems in the building or potential problems that are worth further investigation. So you may have issues with like overventilating, you may have insulation or leakage issues, or you may just have control issues so that your building is not behaving in a tight fashion or a tight response with the outside air temperature. In these examples, we're actually seeing nice trends with the data, kind of as we would expect to see.
Okay, and then if we look at natural gas, in the summertime, it's kind of the opposite case, right? This building is using, so the natural gas is the black line and the cooling degree days is the blue line. So the gas consumption is the lowest in the summer when the cooling degree days are the highest, which is what you would expect because the building is being heated by gas, and so it's not really affected by the outdoor air temperature when it's hot. And then in the winter, you see the opposite where the natural gas is being used for heating, and so it follows the trend of the heating degree days. There's a little bit of an offset here, and so that might be worth pondering in terms of whether you think it's significant in terms of how the building is being used. Jessica, is there anything you want to add to this?
No, that's good.
Okay, all right. And so that's basically, you know, what I wanted to cover with these two software tools, the benchmarking and then looking at monthly data. And and there are a lot of tools available. These are just a couple of examples. And if you go to eis.lbl.gov and then click on this small commercial energy management package and then click on the software tools link, again, you'll see all the different tools that are available, some which cost and some which don't. And so, you know, if you really decide to get into this in a big way, you might want to investigate some of these other tools. So I think, let's see, where are we? I think we're ready to, so we probably don't have time to do building fingerprint, Jessica? Or do you want to just
let's revert the control back
to you. Yeah.
And we'll carry on.
Yep.
Okay, so just one comment is we will post on our website all of the materials for today's training session, and you'll actually get a more extensive slide deck to view than the one we're using live today. It'll step through all of the screenshots from step by step from the two analysis exercises that we just went through. And you'll also get a little information on a tool that can be used for smart meter data. We're kind of including that as an eye to the future in that Duquesne region as that rollout happens. So that was about as technically detailed as we're going to get for the remainder of the class today. I'm going to step now, kind of bring it up to a more general level, talking about business models and value propositions. We did a lot of interviews and feedback with our demonstration partners, as well as other contractor stakeholders and folks who are working with small commercial buildings to develop a business plan and get some sense of market potential. Sam, for those in the class today, Sam has a few handouts for you to also take a look at. But first couple things we wanted to understand is, why would a contractor participate in offering this service? And conversely, why would a customer participate? I'm showing in bold on this slide the areas that we heard were most strongly resonant. And on the contractor side, it was the ability to differentiate one's company from the peers and to offer a value add to their client base. There was also benefit in being able to identify additional service opportunities to go in and actually implement the fixes for the opportunities you're identifying, and to gain credibility through affiliation or participation with these third-party programs like the 2030 districts, offering the tools that are in those toolkits, like the energy management package that was developed by a national laboratory through support from the Department of Energy. On the customer side, there's, of course, the benefit of reducing utility expenses. But just as, if not more importantly, the ability to improve the quality of that indoor environment, the comfort conditions, for example. That's often something we call co-benefits or non-energy benefits to improving the performance of the building. There's, for some folks, the ability to just reduce hassle factor associated with maintenance and who you're getting to service the building. And in some cases, people are motivated to reduce their environmental impacts. being able to effectively target what kind of customers or clients are likely to make good use of this package or be interested in it, there's really 4 characteristics. Those who are value-oriented, as opposed to that roughly 1/3 of the market that we know are focused purely on costs and the bottom line. Customers who are with whom you have a good relationship, who are willing to follow the contractor's lead and be motivated to cut down on their utility bills. Those that are data-driven. We kind of know that some people are interested in the numbers and the figures, and some are just, don't bother me with the numbers, just keep my building in good operating shape. And finally, of course, those with the sustainability or environmentally oriented type of goals. We can go back, and if you can think of some of the opening remarks we had about the small commercial sector, we want to know, what are the energy and cost savings potential of delivering this package? If we look at that savings level on the order of 5% and think about the expenditures of this portion of the commercial building sector, we're looking at, on average, savings on the order of several $100s a year. If we think about those food service and food sales establishments that are much more energy intensive, or the buildings that are bigger, close to the 50,000 square foot size range, then there we'd expect the savings to get into the order of a couple $1,000s a year. The graphic shown here is just an illustration of the range that we could see across the building stock. So if we're talking about, hundreds to thousands of dollars a year, that's pretty critical to the bottom line of a lot of small businesses. But I'll keep coming back to the concept of these co-benefits, largely improved thermal comfort that really are significant in just creating a building that people want to occupy, whether they're employees or whether they're actual customers of the small business. And we use this graphic here. I think this is a J. Crew ad. It's just classic. Is your office freezing? Your service department might not be able to help, but J. Crew's featherweight cashmere can. So we're just notoriously uncomfortable in our buildings. People have worked to kind of quantify the value of improved comfort and have found that, a little increase in productivity from having a more comfortable environment can easily match or outweigh the cost that one sees on the energy bills. In developing a business model for this package, we talked a lot to folks about the existing types and flavors of contracts that are offered and how this package could be dovetailed with those. And we really found pretty universally that the preferred delivery mode would be to, as opposed to offering a standalone, you can buy the EMP on its own, to really just embed those costs into existing maintenance contracts. So, for example, one contractor we worked with said, rather than charging $1,500 a year, I'd charge $1,700 or $1,750, and I'd just incorporate this into what I would offer them. You're adding value in the maintenance spiel, and you can monitor usage. So the idea being that many folks told us that for the data analysis activities, for example, they wouldn't use their field technicians necessarily to do that, but would have their overheaded office staff working with the software tools, and then maybe hand off to a coworker for the on-site walkthrough. We can look in kind of a line item manner at how the costs actually balance out, either from the contractor perspective or the customer perspective. So if you think about the contractor's perspective, say a couple $100 a year for the premium on those existing contracts, that benefit of retaining or be able to recruit additional clients coming in at another few $100 a year. We could add to that profit from actually performing some of the improvements and subtract out the labor costs, say about a day of staff time a year, and see how that results in a net profit for the contractor. On the customer side, we can do the same type of math. Utility savings of several $100s a year, minus the cost of any upgrades and that premium on the contract, and things pencil out again in a favorable manner. What you will see is again that some of the co-benefits are just as, and I would venture to say more important than the actual dollar value profits here. So the increased credibility, the ability to differentiate oneself from the competition, and the ability to recruit and retain additional clients were just really key that we heard time and time again from our partners. Now, what we also heard was that people could really use some support in how to market or sell this service offering or communicate the value of it to their clients. And I've taken some tips from a really nice resource out there. It's a book by Mark Jewell called Selling Energy, and I'm just going to walk through a few of them with you this morning. Not every single one of these tips will resonate with each individual, but I think some of them really can be helpful. The first is to get ready with your elevator pitch. We certainly use this in the research world, and it can be just as effective in business. So this is a quick and concise 2-minute description to develop that short and kind of interactive, what can you give someone? You can draw from the materials that we've synthesized for the package as well as the business model document. And then there are tips around how do you really become a pro at efficiency sales. The first traces back to a slide we covered just a couple minutes ago, which is to have in your mind ahead of time the profile of the ideal customer who this package would really work for. So those data-oriented, goal-setting, types of clients who really want to do something about their utility costs and improve the comfort of their building. You can definitely use the outputs of the benchmarking and meter analysis steps in the package to really use your success with past clients as concrete examples in your communications. There are lots of opportunities out there through LinkedIn and professional organizations to really make yourself known in the community, set up a LinkedIn profile, add information about the offering to your company website, get hooked up with networking events. You could attend them, maybe monthly, maybe every couple of months. Testimonials are really important. You can get those, nice quotes from clients who you initially onboard to this service offering. I think, I've got on here a handwritten thank you note, and I thought that was really interesting in this kind of age where we're so flooded and dominated by digital communications and email and text and blog posts that some of that firsthand touch can, I think, go a long way, even in catching someone's attention these days. And then if you have, a really good relationship with a client who didn't necessarily bite and wasn't that interested, then it's always helpful to kind of go back and find out a little more about, why it wasn't particularly compelling in their case. That's good lessons learned for the next time. A little tip here in communicating where we draw some from what we know from our friends in the social sciences. In this type of area, people are often motivated more by avoidance of a loss than they are by, a potential benefit. So as an example, you might suggest that a set point change on the HVAC units could reduce losses by, say, $50 a month, as opposed to saying that it could save $50. So a lot boils down to the framing in some cases. There's an interesting approach that's called prospecting, which, in spite of all the words on this slide, it's basically using examples and bringing them into the context of a specific client. So what you can do is make note of a specific way you've improved the operations or efficiency of a building that's similar to someone you're approaching for the service. And then you can connect that to an observation you've made about the specific site to the person you're talking to, and then finally connect that to the energy management package and link the two by showing how you can improve the building for a given customer just as you've done for others in the past. And that's a real short kind of three-step or three-sentence mode of communication. There's a couple benefits to that approach. If you can use words like exploring, that kind of reduces the pressure and sets a certain tone. Highlighting specific prospects from what you've noted from being in these buildings can make it more tangible to folks, and drawing from prior examples just shows that you have a track record in doing this sort of thing. Again, back to this theme of focusing on those co-benefits of improved efficiency, and this is, really if we're able to improve the comfort and environmental conditions of a building, that extends into, increases in productivity, reduced absenteeism, and even a better experience for the customers of that small building. So some kind of tips on selling and business model and value proposition. I want to close out with some lessons learned and insights from our demonstration that we conducted in the past year or so. We conducted these demos to validate elements of the business model. If you recall, we said you should be able to identify savings that add up to about 5%. You should be able to get in and out of the building in about 4 hours, and there are certain cost targets that you can use to as bounds for the terms in the contract. So we teamed up with 16 partners across the country. Their location and is shown on this image on the top part of the slide. Those contractors brought 24 sites to the demonstration, and it was several 100,000 square feet of small commercial building space. Our demonstrations did bear out the elements of the business model. So the time saving, the time that it took to deliver it was validated, as well as the fact that by doing these activities, you can identify significant improvements in the building. Owner-occupied buildings are much easier to deal with. In addition to aspects of split incentives, where a different person may be benefiting from the reduced utility costs than the person who's paying for the improvements. In addition to that, there can be real logistical issues in terms of space access when you try to work with tenanted spaces. skill level really varies across the community of folks who we would like to onboard into delivering this service. And so our team found that it was really critical to be able to minimize the number of tools that are required. I think we've been successful in doing that. We did find that there's a learning curve to some of this. And, you know, any time in any of our jobs that we have to use a new tool or piece of software, you know, we have to find the time and initiative to do that. So that's actually why we're all here together today. These things are easiest if we can come to a formal training venue, you know, sit down for part of a morning and really accelerate up that learning curve in a set time and location. And then we found that interval data, I think that this was kind of fun for our team especially. We're like building scientists and national laboratory folks, and we get really excited about data. But we didn't necessarily expect to see that the power of that smart meter data, and I encourage you to, you know, keep an eye out for it in that Duquesne territory in the future years. It was just really compelling to contractors as well as on-site building staff. People got very engaged when they were able to see the time series of those load profiles. We asked all of our partners what components of the package they'd offer in the future, and you know, almost everyone said they'd do the whole package. A couple of people didn't, you know, maybe have access to interval data, so they wouldn't offer that in the future. One person, you know, can't please everyone, I suppose. One person did say they wouldn't do it again, but for the most part, people were quite happy with what they were able to accomplish in delivering this to their clients. And there were a few key attractors. Of highest interest was this concept of being able to expand into delivering energy management services. There was a lot of professional interest to simply stay on top of the latest advances in the topic area, to learn new tools, and to stay abreast of things in our industry. It's a pretty exciting time with growing availability of data and analytical tools to make some sense of that data. I'm going to share a couple of nice quotes from some of our partners. One told us, I think for me a lot of the EMP dovetails with things that I've been doing with benchmarking and monthly bill analysis, but the package formalizes it and puts it all together in one place. It has a nice flow to it. It's putting a lot of resources together in one place. And then it brings in the interval analysis piece, which wasn't always on the top of my mind. So this is something that I'll continue to be interested in and continue to use. The second quote that I'm putting here highlights some of those business benefits. In this case, we were told by the contractor, we picked up 2 new accounts because I was able to say, you know, why don't you let me take a look at your energy usage? And now we're working on a proposal with them. So it's actually benefited in more than a few ways. I'm going to leave this last concluding slide up. Again, this is your reminder pointer to our website where you can access the package, the recordings from today's training session, the very detailed slide deck and guidance to how to use tools. Feel free to reach out to me with any questions that you may have, you know, after this morning. My contact information is there. This marks the conclusion of all of our prepared materials for today's training, but in the time that we do have left and available, I want to open it back up for some Q&A, discussion, and comments. We've gone through, you know, how to access data and tools in general, ran through a couple of exercises with real data, and spoke some about the business model and value proposition. So basically anything you've seen this morning is on the table, and I'll work again with those who are closer to the mic to make sure that we hear everyone.
Anyone have any questions?
Well, I think that they did such a thorough job of explaining. It seems like nobody has questions. So how can we access the energy management package going forward?
So the package is on the website.
Okay.
And there's more information, different tools, and then there's other information. So a lot of information on the website. Feel free to email us if you have questions.
Fantastic.
We had a few questions. We wanted to know what brought you all here to the program today. What we are looking for. Anyone has any insight? Did this have what value to you all today? We are looking for different other tools. Or what brought you to the training today?
Yeah, what brought me to the training was the idea of expanding. It wasn't a big stretch to add new features and benefits to a potential client. I had a question though about you mentioned that 1/3 of the market is focused on bottom line, and my experience is like 90% of the market is focused on bottom line. So where did you get that 1/3 from? Because in Pittsburgh, I'll tell you, everybody is, you want to talk about value proposition, and it's a hard sell in Pittsburgh.
That's just, I would personally go with and trust your personal experience more than whatever we're showing there. That really just is a very general number about the market and the fact that when people buy things, they tend to have certain orientations. So your experience trumps anything that we could find in a book or an article. I think I'll just add one remark that, to your point, a lot of that sense that people are in many ways, driven by a bottom line. Efficiency doesn't dominate the minds or concerns of any of these small businesses. That is really why the recommended business model says, don't try to necessarily sell this as it's standalone thing. You're probably going to be best off to just add a slight premium to existing contracts, kind of deliver an all-in-one, and it's more like oh, by the way, here's what I did about your building energy use as I was, servicing your rooftop units, the bread and butter of why these small buildings would be procuring your services to begin with.
Is there any other questions? So a recording of today's session will be on our website a week or so from now once we get the file. They're recording the previous session we've done, so feel free to go through there. There's tools. On behalf of Berkeley Lab, I'd like to thank Andrea and the team for hosting us. And, if you have questions, feel free to reach out.
Yeah, thank you all for coming. If you have any topics going forward that you would like to learn more about, we're always looking for suggestions of how we can serve you, our members. So please don't hesitate to contact Brendan, myself, Janelle, anything that you'd like to learn more about. And as we learn more from this coming out from LBNL, we'll certainly take pains to press out information coming out of Lawrence Berkeley National Labs. And now you have contact info directly to source to, so give them a call. Great. All right, thanks everyone for coming. We appreciate it.
Thank you very much.